And we want to thank all our sponsors. We want to thank Dan for joining us. And Karen, are you ready?
Yeah, I'm ready. Hi, I'm Karen from Nuremberg, tuning in from Europe. And I want to introduce Dan Sullivan. Dan Sullivan is a principal engineer with Pix6 technology. He's a software architect and data scientist with extensive experience in data science, machine learning, and cloud architecture. Dan is the author of the official Google Cloud study guides for the professional architect, professional data engineer, and also associate cloud engineer certifications. Yeah, he is also instructor of a dozen of courses on machine learning, data science, and cloud computing on LinkedIn Learning, and as well as Udemy. He holds a PhD in genetics, bioinformatics, and computational biology with a focus on infectious disease genomics. And I think it's very much up to date nowadays, right?
Exactly.
Yeah, sure.
All of the most requested.
It's a great pleasure to have Dan with us today.
Well, thank you, Karen and Linda and Chad. I really appreciate the opportunity. Great. So thank you again. Again, my name is Dan Sullivan, and I'm really looking forward to talking about Google Cloud certification exams and the Associate Cloud Engineer exam in particular. First, I just want to thank all the GDG groups that organized this, and especially Linda, who did all the work to set this up and made it very easy for me to do this. So I appreciate that.
Thank you. Thank you to everybody.
Couple things I just want to just make sure everybody understands. So I have written the official study guides. Basically, that means I worked with Wiley. Wiley, or Cybex, is the publisher. They had a relationship with Google, like they had a formal relationship to do the official guides. And so I was the author for those. As I mentioned earlier, I work in cloud architecture, data science, and I've worked with Google Cloud for years. One thing I want to highlight is that I'm not employed by Google. I'm not a contributor to the certification exam. Like, I don't develop it. I have no more insight, like from a, I don't have access to any non-public information about the exams. So I often get questions about, you know, will this new thing, like will Anthos be on the exam, or will Cloud Run be on the exam? And nobody tells me, so I don't have specific details. I can tell you anything that's in beta is generally not on the exam. And I can also say the exam is constantly evolving, so Google is constantly trying new questions. So you may come across a question that's somewhat unexpected. That may be a test question, something they're just trying out, or it may be something new that they've introduced. But I'm afraid I can't offer any more insight than that about the structure of the exam. And then finally, feel free to connect with me on LinkedIn. That's where I do most of my communication in terms of social media. So if you're interested in following along in terms of like tips, access to courses, anything like that, LinkedIn is probably the best place to connect with me. So I'm thinking this talk is going to be sort of broken up into two main blocks. And the first half is about the certification exam and what they're like, and basically some things you need to know so that you are not hindered by this sort of unnatural environment that we have to work in to get certified. Because, you know, exams, you know, we don't typically do our jobs. We're not working in an exam environment. We're working in a completely different environment. So I just want to help people understand how to adapt to this test environment so that doesn't get in the way of you passing. And that's basically going to be the first part of the talk. And then as time allows, I thought we could do some reviewing some of the topics that are covered in the exam, like the compute and storage services, networking, IAM, and things like that. And we can reorder these depending on people's interest. I have slide decks for all of these topic reviews, and we can jump in anywhere. So first of all, I want to talk about the Google Cloud exams. Now, in particular, we're going to focus mostly on the associate cloud engineer. I'll touch briefly on cloud architect and data engineer, because I often get questions about, what's the difference between the associate cloud engineer and the professional cloud architect. Also, there are some other certification exams for things like security and networking, and those are not my area, so I won't be covering those at all. But I do want to just talk a little bit about the difference between the professional level exams and the associate level exam. And basically, the associate level exam is typically designed for people who have about 6 months or so experience with Google Cloud. And it is a test of how well you can take pretty well-defined technical requirements, like deploy a virtual machine with 8 virtual CPUs and 16 gig of RAM and 300 gig of persistent storage. And then how would you do that? How would you do that from the console? How would you do that from the command line? Those are the kinds of questions that show up in the associate cloud engineer. It's very much how do you do specific tasks within Google Cloud. The professional level certifications cover that, as well as your ability to understand business requirements and map business requirements into implementation details. So for example, on the cloud architect exam, there are 3 different case studies or scenarios that you have to basically read and answer questions about. And they can be, I believe the scenarios, at least last time I looked, one was on a retailer who's developing an online site and has sort of a social media aspect to their e-commerce site. One is about an equipment manufacturer who has equipment deployed across the globe, and there are IoT, Internet of Things, sensors and monitors on those devices, on some of those devices, and it's transmitting data back. And then the third one, I think, is an online gaming company. And so in the architect exam, so you get all these details at a business level, like what are their business objectives and what are their sort of goals and what kind of problems do they have in their current environment. And then you're asked questions about how you would improve on that, how you would design systems that are scalable and reliable, have very low latency to a global audience, and things like that. So it's more abstract, more conceptual at the cloud architect level than it is at the associate engineer level. And for the data engineer exam, it's at the same level of abstraction and business requirements as the architect, but it's very focused on machine learning, data science, analytics, business intelligence, and data warehousing. So it's like the architect exam, but really focused on a narrower band. Okay, I kind of alluded to this when I started talking, which is, these exams that we take, these certification exams, this is not how we work when we're working with Google Cloud. So in a way, the exams aren't really reflective of how we work. And the problem is, ideally, we might have an exam where we're sitting down with someone who's giving us the exam, and we're doing stuff actually in the Google Cloud, and we're solving problems in the cloud. And the problem is that kind of thing won't scale to all of the people across the globe who want to become certified. So we have these online tests, or these proctored tests, with 50 questions that we take over a course of 2 hours. And that's really different, because in real life, we do things like, we can just search, we can go through documentation, we can see how other people have solved very specific problems using Stack Overflow. And this is how at least I work anyway. I don't know all of this stuff in my head all of the time. And so I depend on these things. So one of the things I want to focus on is helping you understand how not to let this disconnect between what you really do when you're working and the way we are tested get in the way of you actually passing the exam. And the problem is there's really only one way to pass, and that is if you actually know your stuff. So what I show here is something called the confusion matrix. And the idea here is, over on the predicted side, it's like, well, what are your results from the exam? And ideally, if the exam says, you pass or it's positive, then that actually reflects that you do actually know the material and are qualified. And that's really a true positive. Now, a true negative, now that shows up when the exam says, yeah, you don't really know your stuff, and actually you don't. And that can happen, right? If I didn't study enough, I wouldn't have passed the test. One thing that Google is very good at is designing exams that don't lead to false positives, which means I don't really know the material, but I sort of gamed the exam, or I figured out how to guess really well, and I managed to pass the exam. That is highly unlikely. The danger area is this false negative, which is you actually know your stuff. And if you were sitting at the command line or working with the console, you could blow through and do this stuff and spin up virtual machines and be able to monitor a Kubernetes cluster. And you actually know the material, but there's something about the exam, it didn't capture that. And then you end up not passing the exam even when you should have. And that's the thing I want to focus on in this first part of the exam. I want to help avoid that situation. So we're going to talk a little bit about how to get started and what the exam is like. So another common question I get is, well, what do I need to study? How long should I study? And my first answer is always get your hands on the keyboard. Start working with the console. Get into Google Cloud. And it's very easy to get started. Google will give you a $300 credit for signing up. You just need an email address. $300 will get you a long way in Google Cloud if you're not spinning up large clusters and things like that. But from a studying perspective and just kind of working through examples and things like that, $300 is a lot of money. Also, there is something called the free tier, and that is a set of resources that are available to you. Even after you've spent the $300 credit, you will always be able to have, say, like a gig of storage in Firestore, or you can run an F1 micro instance just continuously. You'll never be charged for that. And so you can check out what's available in the free tier at googlecloud.com/free. So the first thing to know about passing this exam is I can't imagine how somebody could pass the exam without having spent a good amount of time actually working with Google Cloud. There is an exam guide for every test or every certification exam, and they're available on the Google website as well. I strongly recommend looking that over. As soon as you decide you want to take a particular certification exam, the first thing I would do is go to the exam guide, because that lays out really what's covered in the exam. And I have found that the exam guide is really reflective of the exam itself. So if you have a good handle on the topics that are covered in the exam guide, you should be in pretty good shape with regards to the exam itself. Now, there's a lot of resources that are available. Coursera has a lot of courses, and they are free. And these courses, many of these courses were developed by folks at Google. And in general, Coursera courses are excellent. I've never seen a bad Coursera course. So I would highly recommend taking any Coursera course. Another thing you can do, and I did make a slide for this, is on YouTube, Google makes available all of the talks from Google Cloud Next, which is the annual conference for Google Cloud. And the talks are excellent. Some of them are beginner talks, some are more intermediate, and some are really in-depth. So if there's an area you're not particularly strong in, say, networking isn't your thing or security isn't your thing, and you want to sort of dive down deeper, I would strongly recommend checking out YouTube and searching for Google Cloud Next and seeing what kind of security talks or networking talks are there, and watch those and really, really take advantage of those. There's the Udemy course that I did that's available online as well. And also, if I have a website, dansullivanlearning.com, you can go to that. That'll have links to various resources. And as I do new stuff, new courses and new resources, I'll make them available from there. Okay, I just want to do a tech check and just see with Chad or Linda, are sound going okay and the slides continuing to work? Great. Okay, thank you.
We should be okay. We had some trouble with the live stream, but I think otherwise we're all right.
Okay, great. Thank you.
Yeah, just some people trying to join now, if someone accepts.
Yep, I've just let another 10 or 15 people in, so that's happening also.
Yep. And feel free, Chad and Linda and other organizers, feel free to jump in anytime and interrupt. This is very informal from my perspective. So, okay, so that's sort of the nature of the exam at a very high level. Now what I'd like to do is kind of drill down into specific things that you can do to help prepare for the exam. So first of all, there's the study strategy. So how do you prepare for the exam? Definitely the first thing is really study the exam guide and understand what are the tasks that are involved. By the time you take the exam, you should be able to go back to that exam guide and like look at each of those detailed bullets and feel like, yeah, I understand how to do that. And I think that's a good sort of criteria for assessing, am I ready to take the exam? So there's that. Look at the exam guide and make sure you feel comfortable with the topics. And then also take the practice exam. Google provides I think it's about 20 questions, a 20-question practice exam for all of their certification tests. And that's a good one to take. And it also helpful to take early on, like when you're first starting, just so you can see what kind of questions they ask. So for example, Google's exam questions are usually scenario-based. So they won't ask something like, what's the largest, what's the maximum database size in a Cloud SQL database? And you're supposed to know whatever, 30 gig. They don't ask questions like that. It's much more scenario-based. And so you do need to know, like some of those numbers, like where's the cutoff, like how big a database can be, but you're not going to be explicitly asked that. I've never seen a question like that. Another thing about study strategy, and both the exam guide and the practice test can help with this, is you want to identify your weakest areas. And often what happens is, like in our work, we focus on like one or two things, like one or two areas. Like I do a lot of work on databases and data stores and moving data around, like from a cloud engineering, like data proc, data flow kind of way. But I don't do a lot of work in networking. I might do some initial setup when I'm starting a new project, but for the most part, networking is really not my bailiwick. So when I was like studying for this exam, when I took it, it's like that's something I had to really focus on because it's just not something I do a lot. And you will be tested on this. One of the most challenging things about the associate exam is the breadth of material you need to know, because it really does span all of the major services. So while something like the professional data engineer is more narrow and deeper, and it's challenging in that way, the associate cloud engineer is very broad. So you just want to make sure that you don't try and depend on really acing your strong areas and then risk failing on the, or not getting the questions right on the areas you're not strong with, because you really risk not passing at that point. And then again, going back to the idea of, you really want to have some hands-on experience. It's great to read the documentation, read the books, take the courses, work with Quick Labs. Quick Labs is an excellent way to get started. Even after you've done that, it's really important to work with Google Cloud in an unstructured kind of way. Just jump in and start spinning up instance groups and, shut down a server in an instance group, make it look like it crashed and see what happens. I strongly recommend trying to break things, like try to get error messages when you're trying to do things, because the error messages are often good at helping sort of reveal the design or the architecture of things and how things work together. And it also helps us understand the limits of our knowledge. So definitely get in and try and do things you don't understand how to do. So that's the basic study strategy. Now, on the day of the exam, Google now has online exams since the start of the pandemic. Google offers online exams for associate cloud engineer, I think data engineer, and architect. I don't know if any of the others have been rolled over to online. So at this time, you can take them online, and I've never done that, so I don't know the details. I believe they're proctored, so somehow somebody's monitoring. The other option is to go to a test center, which might be at a university or an office building in your area where there's a professional test center, and you can sit down at a desktop machine and basically go through an application that has 50 questions. And so it's a time test. You have 2 hours, and there are 50 questions. And the questions, mostly they're multiple choice, and you pick one. Sometimes there are multiple answers. And one of the nice things about the way Google structures the exam is you can mark your questions for review. So you'll see one question per screen, and and we'll take a look at some of these questions in a minute. You have one question per screen, and then down, I think it's in the lower left corner, there's a little checkbox you can mark as, mark for review. So you can go through the whole test, or at any time click on another link within the screen, and it'll go back and it'll show you a list of the 50 questions, and it'll flag which ones you've marked, so you can quickly jump around to ones you want to review a second time. So that's one thing to know about taking the exam. Another thing to know is you really have to read the questions carefully. And the first thing you want to do is, I try and identify what are the key services and software they're talking about. Is this a question about, say, BigQuery, and is it about BigQuery and data warehousing? Is it about containers? And if it's about containers, is it about App Engine or Kubernetes Engine, if either of those? So you want to kind of immediately identify what's the sort of the topic area that you're dealing with. And then you want to look for very specific technical requirements. And this could be things like, from the command line, how do you do X? Or it might be you have a database that's 50 gigabytes and you need to load this data, something. You want to kind of quickly identify those things. Anything where there's a number that, some kind of parameter or configuration information, that is often important. My working assumption is that anytime there's a number in a question, there's something important about that. So you want to take note of that. And then again, reading you also have to read carefully, because sometimes there may be two services mentioned, or two different things. Like you might be talking about projects and storage, and it's not clear, is this a storage question, or is this about administering projects? So you want to make sure you're able to determine really what the question is about. And another thing from a test-taking strategy is that typically there are 4 options to a question. Sometimes there's 5. Oftentimes there's 1 or 2 options that you can pretty quickly throw out, and you can do that by looking at the technical details and the key services, and you can often identify, well, this is really not relevant, and you can eliminate those. But you're often left with 2 that are very similar, and sometimes with questions, 2 of the options are so similar they might only differ by 1 or 2 words. So again, you have to read the questions carefully, and then figure out what word is off or what word's different, and then keep that in mind and reread the question, and then you can probably figure out which of those 2 options are the actual answer. Okay, so what do you need to know? Well, definitely at a really broad and deep level, you need to know identity and access management. It's all over the place. And this is across all the exams, or at least the three I talk about. Data engineer, architect, and associate engineer are really heavy on identity and access management. And it as it should be, because IAM is so important in like real life. So the things you want to understand is you want to understand the distinction between roles and permissions. So permissions are basically grants which allow you to do a certain operation. And those permissions are grouped together into roles. And you don't assign permissions directly to users or groups or identities. You assign roles to them. And there are different kinds of roles. There are predefined roles, and those are ones that we typically use. And those are ones that Google provides. They've basically looked at how people set up their teams when they're working in the cloud, and they've identified common tasks or common sets of responsibilities, and then they've kind of grouped permissions together so that someone in a particular role should have all the permissions they need. Now, of course, there may be times where the predefined roles that Google provides are not sufficient, and you need to customize them, and you can do that with custom roles. Those are the ones we usually use. In rare cases, or in a limited set of cases, you can use something known as the primitive roles. And those are the roles that originally came with Google Cloud years ago. And this was before the Identity and Access Management service was released. The primitive roles are very basic and they're very broad. And you typically only use those like in a development environment or where you have a very small group. But generally in a production environment, like in a real organization or enterprise, you're using some combination of predefined and primitive. So you want to know the types of identities. So things like service accounts, user identities, which are associated with like a Gmail address, groups. You just want to understand those different ones. So that's identity and access management. On the networking side, this is a tough area, or those of you like me who don't do a lot of networking, because even within networking, the topics are so broad. So you need to understand about virtual private clouds and subnets, subnet addressing. So if you're not familiar with like what a CIDR block is or how to read an IP address with a slash, and then some number after it, like /24, if you don't know what that means, it's really important to kind of bone up on that, because sometimes there are questions where you have to be able to like look at an IP address and figure out, is this going to be routed, or is this is this a private address and it won't be routed? So you definitely want to look at that. Also, firewall rules are important. For the associate cloud engineer, I don't think DNS is as important as it is on like the architecture exam, but you should know the basics of that. And hybrid cloud is it's pervasive in the real world, and so it's on the exam. And the idea behind hybrid cloud is that in large organizations in an enterprise, they're going to have some on-premises servers and storage and other resources, and you want to share like those resources with processes that are running in the cloud. And so the question is, how do you set up networks, or a network, or networking between your on-premise resources and your Google Cloud resources? Okay, not all the services are sort of questioned or examined at the same level. However, the compute and storage, those are ones you really want to make sure you understand. You definitely want to understand compute engine and how to create virtual machine instances, how to configure them, how to attach GPUs, for example, and customize them. There are some extra security measures like shielded VMs that Google makes available. You want to understand what that is and why you might want to use that. You also want to understand about preemptible virtual machines. And the idea there is you can get a very low cost, about 80% of the usual price for a VM, with an understanding that it'll run for at most 24 hours before Google takes it back, and Google might take it back at any time. So preemptible machines are great if you have a highly fault-tolerant system, because it can save you a lot of money, and basically, if you can recover from a failure pretty quickly, that's a good option. App Engine. App Engine has two editions. There's standard and flexible. The App Engine standard is the original App Engine, and that is a language-specific sandbox-based service. So there's like a Python sandbox or a, I'm sorry, I'm drawing a blank on the other languages that are supported, like Node.js. And
Java?
Oh, Java, is Java, I think, is new. Okay, great, thank you. Oh, and that's the other thing.
That's a question. I wasn't an answer.
Oh, okay. Oh, okay, sorry, no. Java just came out for Cloud Functions. I don't know if it's an App Engine yet, but that's a great question. I will try and look that up.
Okay, thank you, because I have seen it in Cloud Functions. Yep.
Yeah, no, but that's a good question. I'm not sure if it's an App Engine yet, or App Engine standard. App Engine flexible, you can basically specify your own Docker image. So if you wanted to run something in a Java environment or some other JVM language, and you wanted to use App Engine, you could configure a Docker image with all of the the JVM and whatever libraries you might need, and run that in App Engine. So that's one way to work with containers, is App Engine. The others is with Kubernetes Engine. And Kubernetes Engine is a managed Kubernetes service. And so basically you can specify how big you want your cluster to be, how you want it configured, and not have to worry with a lot of the lower level implementation details of Kubernetes. Now, Kubernetes is an open source project, so you could go out and download the Kubernetes platform and install it on a bunch of virtual machines that you run in Compute Engine, but that's a lot more work to manage that. So you might run into a question where you have to choose between managing your own Kubernetes cluster in Compute Engine or running a cluster in Kubernetes Engine and letting Google essentially manage a lot of it. Generally, it's a better option to let Google manage that kind of thing. Cloud Functions is the other thing. Probably not, you don't need to know it as in depth as the other three, but you really want to be familiar with it. I don't think Google generally asks questions like which languages are on there available or can you use on Cloud Functions, because it just changes so much, or things change frequently in Google Cloud in terms of an expanding set of languages. So the key thing to remember about Cloud Functions are things like, what's the longest duration a function can run, what kind of events can trigger a function to execute, and just understand that Cloud Function is used for basically event processing. So something happens in one of your Google Cloud resources, and then you want to sort of start something, you want to execute something in response to that. Now, Cloud Run and Anthos are both new services since the time I wrote the book and did the Udemy course. I don't know how heavily those are covered on the Associate Cloud Engineer. Anthos is pretty complicated. I wouldn't expect there to be a lot on that. Cloud Run might be covered. Cloud Run is a managed service for running containers. So it is a third option for running containers. One of the things to keep in mind about Cloud Run is that any container you run now in Cloud Run has to be stateless. So you can, for example, have a persistent disk attached with information that you want to be able to persist and carry, say, across instances of a container. So if your container were to crash or be shut down, and another instance of it spins up, you're not going to have access to any state information that was maintained in the previous version. So that's a restriction with Cloud Run. That's probably one thing you want to keep in mind with regards to Cloud Run. With regards to storage, you definitely want to know cloud storage pretty much in depth. And cloud storage is pretty basic in the sense of the features that it has. There are different, I can't think, I'm sorry, drawing a blank on the words, but they're like different levels. There's sort of regional and multi-regional, which is sort of what we use for our actively used data. There's nearline storage, which is a little less expensive. And the rule with nearline storage is typically you want to keep that to data that you expect to access once per 30 days or less. And then there's cold line storage, And the general rule of thumb there is you expect to access data once per year or less. And then there's archival storage, which is another one. I'm not as familiar with that. That's also sort of a new service. But so you want to understand like that level of cloud storage. Also, access controls around cloud storage. You want to make sure you're comfortable with that. And I'm sure I'll think of something else about cloud storage. The other things you want to understand are BigQuery. You probably get questions on that because BigQuery is just a popular service. It is a managed data warehousing service. So it allows you to run petabyte scales data warehousing without having to worry about servers. So a lot of organizations and enterprise that have big data warehouses that are tired of wrestling with maintaining clusters and scaling and things like that turn to BigQuery. Cloud PubSub is really important from an architecture perspective because it's a messaging service. And one of the things it allows you to do from an architecture perspective is decouple your services. So you might have a stateless front end that scales really well. It can scale up without a problem. So if you have a spike in demand for your website, you can scale up really quickly, say using instance groups in Compute Engine, or if you're running containers in Kubernetes. Because it's stateless, you can just keep adding more containers and load balance across those. Now, each of those front ends is going to be doing some work. It's going to be, say, collecting data that it's going to want to write to a database. Well, you might have a Cloud SQL database on the back end. Databases do not scale as easily as front ends do. So you wouldn't want to, say, slow down your front end because your back end can't scale as quickly. So the way we avoid that is we decouple them by using Cloud PubSub. So the front end, instead of talking directly to the database, sends messages or writes data to a Cloud PubSub topic, and the database reads from that topic as it's able to. So sort of work can kind of queue up in the Cloud PubSub topic, and Cloud SQL, or an application that uses Cloud SQL, will consume those messages and work on it at whatever rate it can. So Cloud PubSub is one of the things that allows us to decouple services, and that's important from a scalability perspective. Stackdriver has been recently renamed. Stackdriver was an acquisition that Google made a few years ago, and it included monitoring and logging services, tracing and debugging. There's several things that were part of the Stackdriver package, but basically it's resources for understanding your applications, your infrastructure, and monitoring. So now I think it's called Cloud Monitoring, Cloud Logging, Cloud Debug, and so on. So you want to know those sets of things, sets of services in depth. Now, to a less detailed degree, you need to understand how to choose between different kinds of services, especially storage services. So Cloud SQL and Cloud Spanner are both relational databases, which means they use SQL. The sort of the organizing principle is a table, kind of like a spreadsheet, that kind of structured table where you have fixed columns, and each row represents a particular entity. Cloud SQL is really great for like a regional database. I believe the current limit is up to about 30 gig per database within Cloud SQL. If you need a larger database or a database that can scale horizontally, then you want to move to Cloud Spanner. Now, Cloud Spanner is also a relational database, and it's transactional. So it can do things like, people are putting in orders, and you're saving orders, and you're checking inventory, and you're moving things out of inventory, and you're doing a lot of reading, writing, and updating at very high pace. That's kind of the transactional stuff. Any kind of application like that, typically those go into either Spanner or Cloud SQL if the data is highly structured. Now, BigQuery also uses SQL, but it is not a relational database. It's an analytical database. And the difference is the way we use it. So for example, with BigQuery, the pattern is we typically write data, but very rarely, if ever, update it. So we're constantly maybe adding more data. Also, when we query it, we're typically querying many rows, but maybe few columns. And so BigQuery uses something called columnar storage. And it's just a way of organizing the data that makes it highly likely when you go to read a block of data, you're actually going to get a lot of the data that you'll pull back will be useful for the query. And that's opposed to, say, if you're in a transactional system, typically what you want is you want all of the attributes associated with a thing, like a sales order. You want all the columns associated with that, because you might say update my order, so you need all that information. With BigQuery, it's an analytical database for data warehousing, business intelligence. What you're typically doing is looking at the same attribute across many different rows. So, for example, how many sales did you make in a particular store on a particular day? That's the kind of query that is well executed in the BigQuery environment. So BigQuery does support SQL. You can do joins, but it's not transactional. So you just want to remember that one. That's a critical thing to remember. Now, those, in addition to relational databases and the one analytical database, Google has NoSQL databases as well. Cloud Data Store is one, and Cloud Bigtable is the other. Now, sort of the organizing model in Cloud Data Store, which is also now referred to as Cloud Firestore, is a document. And if you've ever seen like a JSON structure, that's essentially what a document is, where you can have sort of nested levels. You have key value pairs, and then some of the values of those keys can be more structured things. So if you're working with a flexible schema, the data store is a good use case, or that's a good use case for Cloud Data Store. Cloud Bigtable is also used when you have a flexible schema, which means you might have a bunch of columns, a very large number of columns, but not every row will be using all of them. That's a good indicator that Bigtable might be a good option. Bigtable is known as a wide column database, and the organizing principle there is something called a sparse multidimensional map. And basically that's a big phrase, which means a lot of potential columns, but frequently not all of them are used. With Bigtable, the criteria for choosing Bigtable is when you need very low latency writes at very high velocity. So for example, an Internet of Things or IoT application, it's maybe writing large volumes of sensor data. That's a good use case for Bigtable. Cloud Data Store, you might think it's a NoSQL database, it can work, but it doesn't have that low latency write that Bigtable does. So anytime you're dealing with large volumes of data and you need to write very quickly and you're not going to be doing a lot of updating, then Cloud Bigtable is a good option for that. Cloud storage is used for unstructured data. So if you're either like archiving data or you just need to store files somewhere, cloud storage is a good option. Cloud storage is also useful as sort of a landing area or a staging area between services. Earlier I talked about how Cloud PubSub allows us to decouple services because we can send messages between our services. Well, there's a maximum message size, I think it's 10 meg, that you can send in a Cloud PubSub message. If you need to share more data than that, say you're doing some kind of like extraction, transformation, load process, and you've got hundreds of meg you need to send to the next service, that's a good scenario where cloud storage could be used. So you just write that data to a bucket, and then the next service can come and read from it. And in a case like that, you could use Cloud PubSub to send a message with a URL that points to the bucket and the file that the next process should read. So you actually store the data in cloud storage, and you use Cloud PubSub to tell the next service where to go find it. So those are the kind of things you might see with regards to questions about different storage systems. Now, another thing you want to be familiar with is when to use certain managed services. And somebody at Google really loves naming things cloud data something. So there's Cloud Data Proc, Cloud Data Flow, Cloud Data Prep, Cloud Data Lab, and sometimes I even have, and these are things I use all the time, I have trouble keeping the terminology straight. Cloud Data Proc is a managed Hadoop and Spark service. So that's used for big data processing. Generally, people turn to Data Proc if they want to migrate from an on-premise Hadoop cluster, and they don't want the headaches of managing a Hadoop cluster anymore. Cloud Data Proc is a good option. Cloud Data Proc is often used for preparing data or like very intensive data processing pipelines. Because Spark is a big data platform that has really a lot of tools and a rich set of machine learning libraries that make it very easy to work with large volumes of data. Now, Cloud Data Flow is another service, and it's also used to build like pipelines, especially. Cloud Data Flow supports both stream processing and batch processing. Now, the difference there is with batch processing, you will have a chunk of data and you have access to that chunk of data all at once. So for example, you might extract data from a mainframe application and write it to a file and store it in cloud storage. And then you might run Cloud Data Flow, go read that file, do a bunch of processing on that data and write some other file out. That's batch processing. Stream processing is when the data arrives continuously. And so there is no end of the file, like last row, last piece of data, because it's continually streaming in. And Cloud Data Flow works well with that. That's probably the most of what you need for Cloud Data Flow and Cloud Data Proc for the associate cloud engineer. For the architect or data engineer, you would sort of drill down more into Cloud Data Flow and look at some of the features, like how it handles windowing and for stream processing. And I'd be happy to answer questions about those, but this is probably the right level of detail for the cloud engineer. Cloud Data Prep is another tool used for preparing data. That's mostly for things like preparing data for machine learning. Cloud Data Lab is an interactive tool which allows you to sort of explore the data that you have. There's not likely to be a lot of questions. There might be a question about when you would use Cloud Data Prep versus Cloud Data Lab. So just kind of keep that in mind. Also, you want to understand like the way developers work in the sense of, people often write, pieces of code. They want to be able to check that in somewhere so that colleagues can collaborate. For that, you would use something like the Cloud Source Repository, which is like a GitHub repository. And there are other services like a Builder for building containers automatically, and Deployment Manager for releasing those. So again, you don't need to know a lot of the details about those, but you need to understand where they fit in sort of the development life cycle. Okay, the next piece, what I want to do is now look at some example questions and how to analyze them. But before I do that, I say I've been talking for quite a while, so I just want to kind of open it up if there are any questions people want to ask. I'm not going to jump to the site where we're collecting questions, so if somebody would like to ask questions, I'd be happy to take those. And
there's been a lot of discussion in the chat.
Oh,
a lot of discussion. Let's see if I'll tell you what, there's what's that, Linda?
Plus, we have lots of questions in our Q&A website. I hope so. We can take all of them.
Here, I'll stop sharing and jump back in here so I can talk to everybody. Okay. Let's see.
One question was about Kubernetes, and the question was, how necessary is it to know Kubernetes? There's a big discussion here. Maybe in a general sense, you can talk about Kubernetes, why you would use it, maybe why you wouldn't use it. Does anyone else have an input there?
Okay. Yes. To answer the question, do you really need to know Kubernetes? Absolutely. Kubernetes is really important. That's like a foundational service. Many of us came to like GCP, and this is before Kubernetes, and worked with virtual machines. And so Compute Engine was our go-to place. More and more sort of the tech world is shifting from virtual machine-based to container-based deployments. And so Kubernetes was actually developed by Google. They created Kubernetes because they needed to be able to manage all of their containers, right? They shifted away from virtual machines to containers because containers is more efficient. They were able to basically get more out of their hardware by running containers instead of virtual machines. And now more and more of the world is sort of seeing that advantage and moving towards Kubernetes, or moving towards containers. Now, if you have just a handful of containers, half a dozen containers, that's fairly easy to manage. But when you have a large number of containers, say hundreds of containers that might have like hundreds of different containers all running, and you might have multiple instances of those containers are running, it's very hard to manage those individually and manually. And that's where Kubernetes comes in. Kubernetes is what's called an orchestration platform. So it understands containers, and it also understands things like compute and storage resources. And Kubernetes is really good at figuring out where to run a particular container on a cluster in order to, say, optimize the use of all the hardware resources. So I think more and more people will go to containers, and Google is also making containers easier to use with things like Cloud Run, and also Anthos. The Anthos platform basically allows you to run Kubernetes clusters anywhere. You could run a Kubernetes cluster in GKE, the Google Kubernetes Engine service. You could run it in AWS. You could run it on-premise. And Anthos would allow you to manage all of those different clusters. So that's what I mean.
There's a question about the command line, and I think this is related to testing. Do you need to learn the command line for the Kubernetes? Or, well, actually, what do you mean when you say, I'm asking the question person, do we need to learn the command line for those services? Does that mean the Kubernetes command line? Or I'm not sure what the question is specifically, but I wanted to throw that out there. Maybe pop open your mic and let us know what you mean if you can.
Yeah, so the question was regarding the data flow and data proc service. I was just wondering whether you need to know how to utilize the command line to spin up those services, because usually, I mean, I'm used to the GUI. I just don't know whether the exam requires it or not. That was the question. Sorry about that.
Oh, okay, yeah. No, that's a great question, and I'm glad you brought that up. Yes, you really need to understand the command line as well as the GUI. And if it's all right, I'll dive into this a little deeper, because there are multiple command line tools. With regards to Kubernetes, there's basically two ways to work with Kubernetes. There's the gcloud container command. So gcloud is sort of the standard command line for working with most of Google services. And the way it's structured, or the way the commands are structured, when you're typing the command in, it always starts with gcloud, and then some indicator for the name of the service. Originally, Kubernetes engine was called container engine. So in the command line, you would, so it was originally called container engine. The command line still refers to it as container. So you would have something like gcloud container, and then you would have the commands for, say, starting up a cluster or creating a cluster. You do need to know how to do that. Generally, the way the gcloud command is structured is gcloud, the name of the service, some kind of resource like a virtual machine or a cluster, some kind of resource, and then an operation on it like create or delete, and then there's a bunch of parameters. So you do need to understand that, and I would suggest practicing, say, like spinning up virtual machines. Probably the command lines you need to know the most about are gcloud for spinning up virtual machines, also for working with Kubernetes, so gcloud container commands. And also with Kubernetes, you need to understand there is another command line called kube control, KUBECTL. That is the command line utility for manipulating resources within the Kubernetes framework. So things like pods, if you've heard about pods in Kubernetes, if you wanted to adjust a pod or do an operation on a pod, you would use kube control. So it's really important to understand the difference between G-Cloud container and when you would use that and kube control commands. And again, the difference is G-Cloud container is for manipulating the cluster. It's like for starting up clusters and maybe adding resources to clusters. When you're actually in the Kubernetes framework, you use kube control. So, and one way to think about it is, imagine this cluster was running either in premises or in AWS. Well, you can't use G-Cloud in AWS. So is this something that makes sense to manipulate a Kubernetes cluster and in AWS? And if it does, then that means you're working like you're manipulating a pod. That means kube control is the thing you would use. So that's G-Cloud and Kubernetes. Two other command lines you need to be aware of are gsutil, and that's gsutil. That is the command line for working with cloud storage. So if you want to create a bucket, you want to copy a local file up to cloud storage, you would use gsutil. If you're working with BigQuery, there is a command line called BQ. And BQ is where you could do things like manipulate data sets, specify a SQL query to run. So you want to understand G-Cloud for most things, gsutil for working with cloud storage, BQ for working with BigQuery, and kube control for the internals when you're actually manipulating Kubernetes objects. There's also another command line called CBT, which is used with Bigtable. That's going away. I believe you can now do some Bigtable commands in G-Cloud. I doubt there's still a question on CBT, but if it shows up, CBT refers to Bigtable. So there, that's my long-winded answer to the command line question.
No, that's very good. That's really good. I think command line is something that I just think that's an important thing to bring up, right? Because that'll be expected. Yep. I need to quickly apologize to everyone because we have so many questions coming in from different places. And for me, what's been most visible is the Google Meet chat. However, I'm looking right now and I'm just seeing a lot of great questions also in the link that we shared, which is how we're supposed to do it, but I messed up a little bit here. So do you want to continue with your format? Because there's, and then when we come back, I have a lot more questions. Or do you want to go do some more questions now?
How about if we do, if people don't mind, we'll do some more questions now, and then we'll jump into basically how to pick apart a question. So I would like to spend a little time on that and make sure we have time for that. But I also, mostly I want to make sure as many of the questions get answered as possible. So yeah, how about if we do 2-3 more questions?
Okay, that's great. So everyone who's participating and watching, I'm going to jump into the silo where a lot of you have put some questions. And
yeah, all the questions, please post them in the Slido website. That it's and you can upvote the questions that you would like to be. They are getting piled up in the chat, and it's very difficult to follow them. So please follow the link that I posted.
So here's a good one. This one's been upvoted. Let's see. How do you get to a Dan Sullivan presentation material? I'll give you that one, and then I'm going to go look for a more technical question.
I am happy to share these. Chad or Linda, can I send you like the PDF with all of my slides after, and then you can make them available to folks? Okay, great.
And we can start with the chat. Can we start with the questions in order from the top to the, because they are voted, the ones that are voted, we start in
the You're right, yeah. And so the number one question from Karen is, if the main aim is professional cloud architect, would you recommend to clear associate cloud engineer first?
Yeah, I don't have strong feelings one way or the other, and this is the reason. I would say in general, it's good to know the material for cloud engineer. For cloud engineer, you need to know more specifics about like command line. So for example, you might have a question about what parameter to use in a particular G-Cloud command. That'll show up in the associate cloud engineer exam. You wouldn't see that in the architect exam. So yeah, I would recommend doing the associate cloud engineer. Like if you have the time and you have the resources to do it, then yes, I would say do that, because that'll get you in the mindset of like understanding how Google thinks about cloud and resources and architecture. And none of the things that you learn will be wasted or unnecessary from an architecture perspective. But you just may not get the level of detail at like command line questions. In the architecture exam, it's very conceptual. It's like, okay, you're a consultant and your client has this set up, which storage system would you use and why would you, and you have to figure out why and how to choose between them. So I'd say yes, but also if you want to jump straight to the architect, that's fine too. But I would just say, just also know like the G-Cloud commands and things like that.
That's a great question. Yep.
Yeah, excellent.
So another one here is, and we're going to hold you to this. We want an exact answer.
Okay.
You have to pick your date format, but the question is, what is the ideal preparation time, number of weeks you suggest for ACE exam, considering they completed architecture with Google Compute Engine specialization? I can repeat that question.
Sure, I assume that's a Coursera course. I would say, I would give it about 4 weeks, assuming you're doing hands-on stuff. Like you're done, like forget the books, not forget them, but 4 weeks like hands-on stuff. You're, every other day you're in the console or you're firing up the console shell and you're working with G-Cloud commands and you're spinning stuff up and working with things and breaking things. And you are following the exam guide, like work through the exam guide. That's one way to do it, is just start it, number one, and work your way through and make sure you can, you understand some of those things. And also go through the, like practice tests. That's another thing, just to, again, because the test is like an artificial environment. So I would say 4 weeks, a lot of hands-on stuff. Take the practice test that Google provides. There's practice tests associated with the book. There's a practice test with the online course. I know some other people have like practice tests on Udemy. I've never seen them. I don't know how good they are, but that might be another source. So yeah, I would say concentrate on those things. Hands-on, go through the exam guide, and practice with questions, taking the test. Yeah, 4 weeks.
And Dan, you were right. That question was in relation to the Coursera course. So exactly right.
Yep. Yeah, good.
Yeah. Yep. I've personally taken a few of those, so I can recommend. My experience with those was okay. It really opened my eyes to spinning up, some of the App Engine or the virtual machine environments. Just doing the Coursera courses sort of forces you to do a little bit of App Engine work. So that's fun. All right, let's see. Another question is, Dan, do the GCP exams use computerized adaptive testing technology, like, for example, CISSP does? Now, I don't know anything about this, so maybe if you recognize these acronyms, you can explain those first and then answer the question.
Yeah, I vaguely understand. I'm not much on pedagogy and testing, like from a formal professional perspective, but the idea of adaptive testing is that, do the set of questions change based on the responses to questions. So, if you look like you might not understand a domain, it might ask more questions than that, just to probe to make sure, yeah, you really don't or you do. I have no idea what Google uses. Yeah, I don't know. I don't know. I didn't want to venture a guess. Just to be completely transparent, yeah, again, I don't have a formal relationship. I've worked with folks from Google who are involved in the testing, but that was like when I'm writing the books, and there are people who are like domain experts who are reviewing the content, like technical reviews. There's probably like a dozen Google experts that review every book. And then I, occasionally will chat with some of the people who do the testing, but I really don't have any insight into, like, that's a great question, and I have no idea what the answer is.
Yeah, that's great. Yeah. So let us know if anyone finds out. We'll share that information. Yep. Let's see here. I'm still sticking to the Slido questions. Please use that link and add questions there. I do see people are chatting, and that's great. So keep talking, but I'm going to keep going to the Slido for questions. Here's another one. Since cloud is a moving target, how often do these exams get updated to include new services? Now, before you answer that, let me give you a little bit of my personal experience with Coursera, where I was literally in the middle of a Coursera course, and the technology changed, and it was a little painful because I was almost at the end, and then I needed to sort of redo many of the exercises because. And truthfully, it was an improvement. The way that I was spinning up the the testing environment and all that wasn't so hot. But then they sort of came down to their final solution for how Coursera was going to use GCP to spin up the virtual environment in which I was going to do some things, right? And then the virtual environment would tell me, yes, you did complete that correctly, and move on, all that fun stuff. So that's a great question, right? Because most of this is about what did you do for me lately, right? What happened yesterday?
Yep. Yeah. No. This is just an excellent question, and I can only give you my best guess, which is that the exams are updated, possibly with new questions on an unknown basis. Like, I assume it's constantly being updated, almost like software. You're constantly rolling out new features. I suspect that Google is constantly testing questions. So in that set of 50 questions, there might be one or two that you're not actually graded on because it's Google's basically just testing it out and seeing how well it works. So I generally assume that there are questions like that in there. And I assume that anything that is no longer in beta is fair game for a test question. So for example, I don't know what's in beta anymore. A bunch of things came out of beta. Like in Cloud BigQuery, just recently, Google announced that you can do low-level, table-level access controls on tables in BigQuery. And that's big, because before you have to do it at the data set level, which is a higher level. So I would expect in an architecture test or an ACE test, there might be a question on access control and security in BigQuery that would have asked about that before, but now that the table level controls are there, those questions are going to get pulled. I would suspect questions like that are pulled immediately. I don't know how quickly they're going to roll out questions about things like Cloud Run or Anthos. So the way I prepare for it is I just check and see if this is in beta, and if it is beta or alpha, then I don't need to worry about it. If it's general production, then yes, I need to assume that it could be on the test.
Right, that's fair, right? Yep. So here's maybe this is a yes or no question. Does GCP provide a 50% discount to next exams you take once you've passed one? So this is a question about AWS does this cool thing. Does Google do this cool thing also?
I think I've gotten emails, like after taking an exam, an email with an offer. So I think they have done that in the past, like an ad hoc way. I don't think it's standardized. Like, I've always paid full price for the exams.
Yeah. Okay.
So you may get it, but yeah, I think the answer is no in general.
No.
But yeah, there may be.
Makes sense. So look for deals, but there's definitely not a breadcrumb type of, if you get this one, the next one's half off.
Yeah.
Yep. Right.
Yeah.
Great. So let's keep going here. Let's see. The next one then is this. There's a couple of questions about the ordering right? Of what should I take first? And we already had one of those. I'm gonna read out loud 2 questions, and then maybe you can address it on the a higher level. So the first one is, how different are the certification exams for professional cloud architect versus associate cloud engineer? That's similar to the other question, right? What's the difference between these two? And then also similar to that is, oh gosh, these are moving, man. People are getting active in here. It was a similar question to what should I do first? I think the basic question is, if I'm new to this, what should I start out with?
Oh, absolutely, no question. If you're new to this, start with the cloud engineer, associate cloud engineer. The professional level exams are designed for people who have at least 3 years of experience in Google Cloud. That's sort of the level Google is testing at. So it's really in depth. The architect exam is really hard, I will say that. I mean, and they're all really hard. I mean, in different ways. The cloud engineer is hard because it's so much breadth. The architect exam is hard because it requires so much judgment, because you're going to be deciding, how do you partition these large databases so that you avoid hotspotting? Like for an architect exam or the data engineer, for example, you need to know how Bigtable is structured. And the way Bigtable works is there is a cluster of virtual machines that manage metadata about the data, and the data in your Bigtable is actually stored on Colossus, the file system, and they're written in blocks called, they used to be SST tables. And so you need to be able to reason through, all right, how are these things stored? Because the way I structure the key determines which block or which block of data is going to be written to. And if all of my keys are, say, sequential, then I'm going to get a hotspot because I'm going to be constantly writing to the same block. So that's the kind of thing you think about in a data engineer or cloud architect exam. That's from a data store perspective. You might also be thinking about, you have a legacy Hadoop cluster that runs Pig job. Pig is a language in Hadoop. And you want to migrate to the cloud. Which service would you use? And which data set would you migrate? How would you, what would you do instead of using HDFS, the Hadoop file system, which you might use locally? What would you use in Google Cloud? And the answer would be, well, we'll map HDFS to cloud storage and use it that way. And so if you really know the details, like from an architecture level, like what are the options for things like, creating clusters and understanding Hadoop and understanding how things from like Hadoop map to Dataproc, or how, say, Kafka, which is another messaging broker kind of system, how does that compare to Cloud PubSub? You really need to understand at that level and be comfortable reasoning about design choices. If you're comfortable with that, then Cloud Architect's a good way to go. I don't know if that's helpful.
That's great.
Any feedback is great. Yeah, if this is not clear, please let me know.
Yeah, so we have the questions in the sideload, but if people, feel free to keep chattering about this in chat if you want to expand the conversation. Yeah. Here's another question. You'd mentioned this before, and I need some education here because I don't know what Athos is. But the question is, and I experienced a little bit of this, so I can tell you maybe frequently. But when is the last time the questions in the test were revised? I'm sure this isn't for the purposes of cheating, I'm sure.
Oh yeah.
And is Athos included?
Yep, I do not know the answer to either of those. And so again, I would say, my feeling is with regards to the questions, I mean, we never know what's going to be on there. So I would suggest don't worry about the question structure or how frequently things change, assuming like it's a static thing. You might take the test the same day I take the test and we get completely different sets of questions. So it's more a question of, be comfortable with, Anthos. And Anthos is it's like a hybrid cloud service, and it allows you to manage Kubernetes clusters pretty much anywhere. You could have a Kubernetes cluster running in GKE, in AWS, you're on-premise, and you can manage all of them from Anthos. And the reason that's important is that allows you to move workloads around to use the most efficient resources. Like you might have a workload that you really want to keep it on-premise because it needs access to data that's in a mainframe and you just want it to run there. You can manage that from Anthos, and Anthos is running in Google Cloud. So you have one point of management. That's the key thing to know about Anthos. Yeah, other than that, I don't know what kind of questions might show up for Anthos, but I would be familiar with it, like at an architecture level. I don't even know, I haven't looked at it yet, so I don't know what like the G-Cloud commands are for Anthos, but I would definitely look into that. So I would read the concepts guide, like go into the Anthos documentation, read the concept guide, take a quick look at getting started, and then just understand what Anthos is used for. I think if you do that, you're probably going to be in pretty good shape. Anthos is super, super complicated, so I don't think Google would expect anybody at an associate cloud engineer to drill into anything below that kind of superficial level. And again, it's great to guess.
Yep. So I have another question. How are you feeling about that? Do you want to keep with questions or?
Sure. You want to do one more, and then we'll look at some questions, because I think one of the key things about passing the exam is really being comfortable at reading questions and understanding how to pick them apart. So
yeah. Okay.
Yeah,
so this last question, maybe I'll give a little preface here. We're talking about the Google Cloud Platform, right? What gets a lot of attention is Firebase, right? And they're similar, they're different. I think Firebase is underneath Google Cloud Platform. The question is, what is the difference between Firebase and Fire Cloud Storage?
Yep.
Right?
Okay. Yep. Yeah.
And I'd like to throw this extra question in there, which is, what is Firebase really a consideration in these GCP tests? For me, it felt more like, and you can tell me I'm wrong here, for me, it felt more like Firebase was the way that you got to learn this stuff in a safer, less scary environment. And then you were opened up, the big doors were opened up, and Google Cloud Platform was there, very similar, but a little bit more complex than Firebase, right? But what's your story there? And how important is Firebase? Certainly it's important to know difference between Firebase, Fire Cloud Storage. But how much time should you spend in the Firebase world in preparation for these?
Okay. So first of all, Firebase came to Google Cloud as an acquisition. That was a third-party company. And Firebase is really designed for supporting mobile applications or any kind of application where there's going to be like a large number of connections trying to connect to the back end, and where you might need to do synchronizing data between, say, a mobile device and a storage system in Google Cloud. So in general, if you're working with a mobile device, large number of users trying to connect, you got to be able to sync data. That's a Firebase use case. Cloud Firestore is now part of Cloud Data Store. And I may get the terminology wrong because I'm not exactly sure how Google is branding it. I think it is still Cloud Data Store. Cloud Data Store is used for traditional, like if you have a web application and you need an semi-structured database, NoSQL database using a document kind of structure, Cloud Data Store is the service to use. When you create a Cloud Data Store database, you're going to have to pick a mode. And there's Cloud Data Store mode and Cloud Firestore mode. And generally, if you're using, have like a typical backend, you're going to do some updates, push some data back and forth. You would probably use Cloud Data Store mode. Cloud Firestore is if you have, again, like more connections, you're going to have a lot of like lightweight connections trying to connect. Firestore would be the better option. I would say you want to know some G-Cloud commands for manipulating Cloud Data Store. You want to understand that Cloud Data Store is a document model database. It does not use SQL. So if there's a question that says, oh, you need to deploy a database that uses SQL, if Cloud Data Store is one of the options, you can immediately throw it out. So the query language in Cloud Data Store is called GQL, but it's not SQL. And yeah, I think be familiar. I think if you know that and know that it's not relational, it's a managed service. Yeah, I'd say that's probably enough. I would say, yeah, maybe, you know, understand, go in and play with it in the console, create a database, insert some data, create some secondary indexes. Oh, I'd say probably know about secondary indexes, because also know that when you create a Cloud Data Store database and you create a, if you create an entity, whenever you create that entity, it will, Cloud Data Store will automatically index like all of the attributes. But if you want to have an index on a combination of attributes, you have to create a secondary index on your own. You want to know the terms kinds and entities. And those kinds are analogous to a table in relational parlance, and entities are like rows in a table. So I would say know that about Cloud Data Store.
All right. Wow, that was a great amount of information there, because the branding, as you were saying, doesn't necessarily help clarify, but your information sure did. So I guess we'll why don't you take back over and we'll jump in this time.
All right, let's share my screen. Change. Oh gosh, where is share screen?
Everyone, thank you so much for participating in the Sidelow questions. That was really great. Linda, that was a neat find. I haven't seen this before. It's kind of nice how people can throw questions in and just upvote questions.
Actually, Google was using it in for one of our meetings, so I stole it. I stole the idea from them. It's not mine.
Good work. Yeah, good thieving there.
Thank you.
Okay. Let's see. I believe I'm sharing. Okay. I just want to spend a little bit of time now looking at some of the questions on the practice exam, and just talk a little bit about like how I pick them apart. And this is part of the exam taking strategy. Whoops, excuse me. So this is a question I pulled off of the practice exam. And what you'll notice here, this is very similar to the layout that you'll see in the actual exam. So we have a scenario question, and basically, so you have a project, has all of its compute engine resources are in the Europe West 1 region. You want to set up Europe West 1 as the default region for G-Cloud commands. What should you do? Okay, so clearly, okay, we're talking about regions, we're talking about defaults, we're talking about G-Cloud. And now I want to look at like the 4 different options. All right, so A is use Cloud Shell instead of command line interface for your device. Launch Cloud Shell, navigate to a different resource. Already I'm wondering, like, why would I use Cloud Shell instead of command line interface? Because Cloud Shell is basically, it's like an easy access to a command line rather than running the command line interface on your local machine. So basically, they really should be the same. Anything you can do in Cloud Shell, you can do in command line on your machine and vice versa. So this, right away, that doesn't make any sense. So I'm going to kind of skip over that one. And then option B is use, okay, G-Cloud config, set compute region, West 1. C is use cloud config, compute zone, Europe West 1. Okay, so that's interesting. So here are 2 options. And the only difference is one is /region and one is /zone. So I'm going to keep that in mind. And then the third one is create a VPN from on-premise to a subnet. So, oh, wait a minute. Okay, now we're getting into networking. That has nothing to do with default regions with G-Cloud commands. So I'm going to throw that one out. So I've basically thrown out A and D. And now I want to kind of narrow it down. It's like, all right, so clearly it's one of these G-Cloud commands. And the question is it a region thing or a zone thing? Well, in the question, it references you want to navigate, you want the Europe West 1 region to be the default. So the correct answer is B. You want to be able to use the region one. So that was sort of an easy one to start off with, but I just want to show you how to pick that one apart. And if people have questions as we're going through these questions, feel free to just chime right in. Here's one where we're talking about App Engine, and you want to develop a new App Engine, and you're ready to deploy to production. You need to estimate the costs of running your application on Google Cloud Platform as accurately as possible. Okay, anytime I see costs in a question, I immediately think of things like the pricing calculator, alerts on budgets, and things like that. So let's see what we have here for options. We can create a YAML file with the expected usage, pass the file to G-Cloud Estimate. Okay, I don't know, that doesn't sound right. I don't know if there is a G-Cloud App Estimate, and why YAML file doesn't sound right. So this, yeah, that just doesn't, that's one of those questions that just doesn't sound right. Let's see, we can multiply the cost of the application when it was in development by the number of expected users to get an accurate estimation. Well, no, because I mean, that equates number of users with what I'm doing in development, and it may not be, there might not be a linear relationship at all. So that doesn't really make sense. Use the pricing calculator for App Engine to get an accurate estimate of the expected charges. Okay, that's definitely the best so far. Create a ticket with Google Cloud Billing support to get an accurate estimate. Okay, no. Anytime there's an option where it's like, email Google, create a ticket with Google, that's almost certainly not the right answer, unless it is about you've hit a default limit and you want to increase it. So for example, there's like a maximum number of GKE clusters you can create. If you want to create more than that, that's the one time where you would be contacting Google. But anything like this, trying to get a pricing estimate or something like that, it's not relevant. So here the correct answer is C. And here's another one. Your company processes high volumes of IoT data, so Internet of Things data that are timestamped. Okay, so we're working with time series data. Whenever I hear time series, I think, okay, lots of data, high volume of data, a large volume of data at high velocity, but it's very structured as well. So it's the same attributes that come in, and there's always a timestamp. And the total volumes can be several petabytes. Okay, so right away, we're not going to talk about Cloud SQL. Almost certainly, this is not going to be a cloud data store option. At petabyte scale, I'm thinking it's either, right away, I can think, okay, it's BigQuery, Bigtable, or Cloud Spanner. All right, data needs to be written and changed at a high speed. Okay, I can still ingest. That means we're probably not going to be using BigQuery because we're not going to be changing data. You want the most performance storage option for your data. Which product would you choose? Well, it's time-stamped, high volume, high speed. That's not a good option. It's possibly you could use Cloud Spanner, but it's really not a good fit. And oh wait, Cloud Spanner is not even an option, so that's not it. So I've already eliminated Cloud Data Store. Cloud storage, it's an option for storing petabytes of data, but it's not a great option for writing at very high speeds. And it's not going to be BigQuery because we're not going to be updating. So in this case, Bigtable seems like a good option. And really, anytime you see IoT and you want to store IoT data, it's really Bigtable is almost always going to be the right answer in that case. Let's see. Here we have, you have a definition for an instance template. And are people familiar with like what an instant template is? And if not, I can go into that. Okay. An instant template that contains a web application. You're asked to deploy the application so that it can scale based on the HTTP traffic it receives. So what do you do? So this is probably the closest thing to an architect level question you would get. This would be the bare minimum. This would be the simplest architecture question you would ever get on the architect exam. So I have an instance template. I could create a VM from the instance template. Okay, that sounds reasonable. Create a custom image from the VM disk, export the image to cloud storage, create an HTTP load balancer, and add a cloud storage bucket as its backend service. It's like, okay, well, all right, yeah, we probably want a load balancer. That seems reasonable, but there's a lot of steps here. You could also create a VM instance from the template, create an app engine create an app engine application in automatic scaling mode that forwards all traffic to the VM. No, why would we? Yeah, see, if you're creating an application in Compute Engine, why would you then create something in App Engine just to route traffic to it? So that doesn't make any sense. There are too many moving parts with that. It just, yeah, I'm immediately going to throw out B. Option C is you can create a managed instance group based on the instant template, configure auto scaling based on HTTP traffic, and configure the instance group as the backend service of an HTTP load balancer. Okay, that's all very logical. That makes sense because we want this group to scale up and down based on HTTP traffic. So that's a good use case for a managed instance group. And also, since we're working from a template, that means all of the VMs running in this instance group are the same. So that means we can use a managed instance group. And we know we want a load balancer. So C seems like a good option so far. But let's check out D. Create the necessary amount of instances required for peak user traffic based on the instance template. Okay, right away, that's wrong. One of the advantages of going to the cloud is that we can vary the amount of resources that we allocate based on our traffic. So why would we create a number of instances based on peak traffic? Because most of that would be idle. Or, it's at some point in time, or most of the time, at least some of those resources would be idle. So that's not very efficient. So let's throw out D. So we've thrown out B, we've thrown out D, we're left with A and B. A, there's a lot of work like creating custom image from the VM and then exporting to cloud storage. There's a lot of extra steps there. Whereas C is the most automated way to respond to changes in traffic because you're using a managed instance group. So in this case, the correct answer is C. Okay. I'll do one more, and then if people want, we can either continue with this kind of thing. I've got a few more of these, or we can go back to the questions, whichever is more useful for you. Here we go. Your application has a large international audience and runs stateless virtual machines.
Well, I'll jump in. I'll say that there's been a lot of activity in the questions. If folks could go ahead and do upvoting, that would be really great. And then when add your questions or upvote questions that are in there, and then when it's time to come into the questions, we'll have some newly prioritized stuff to talk about.
Great, thank you. That was a good idea. Okay, so here we're running an application, large international audience. We're running stateless virtual machines. Okay, so we're working with VMs, not containers. Oh, within a managed instance group across multiple locations. Okay, so we've got that one architected. One feature of the application lets users upload files and share them with other users. Okay, files must be available for 30 days. After that, they're removed from the system entirely. Which storage solution would you choose? That makes me think of they're removed after 30 days. That makes me think of data lifecycle management, which is the thing I couldn't think of earlier, which is part of cloud storage. Within cloud storage, you can create policies on buckets that say, okay, after 30 days, delete the files in here or move them to nearline storage or cold line storage and do that automatically. So you set a policy and Google Cloud Storage will manage it for you. So let's see what our options are. We could go with a cloud data store database. Well, we just talked about cloud data store database, and that's based on the document model. So it's a semi-structured thing. Here we're loading up, allowing users to load arbitrary files. So it doesn't make sense. We don't store files in a database system, whether it's cloud data store or cloud SQL or cloud Bigtable. Files don't belong there. Files generally go toward cloud storage or object storage. So I'm going to eliminate A right off the bat. B, use a multi-regional cloud storage bucket. Okay, that makes sense. What that does, by multi-regional, that means when I put a file up there, it'll get replicated across multiple regions. So that'll help me with my large international audience because I'll have copies across multiple regions. We'll get some pretty good latency from there. And because it's cloud storage bucket, I can use lifecycle policies to take care of this 30-day delete the files after 30-day requirement. So I'm liking B. B looks pretty good. We could use persistent SSDs on virtual machine instances. Sure, we could definitely do that. But SSDs are really expensive. And because it would be stored on SSDs, we would either have to manage replication ourselves to virtual machine instances in other regions so that we get that high performance for our international audience. So that's already, so that doesn't make a lot of sense. It's expensive and it's more work than using a storage bucket, so I'm going to eliminate option C. And then finally, a managed instance group of file store servers. Okay, file store is a server that gives you like a network file system, NSF file system. So you're not managing instance files group. So this is one of those options where the semantics, like, it doesn't make sense. You don't manage instance group of file store servers, so we'll throw D out. So in this case, the obvious answer is B. So anyway, so those are examples of how to pick apart questions. And so right now, I'll jump back in and we'll take some questions if that works for everybody else.
Linda, you were saying Linda, did you have a concern about time? Because we do have questions. I just don't want to go over. And Dan, how are you doing
with the time? Did you finish all the slides, or do you still have slides?
I have some more slides to go over, but really, I really want to tailor this to what people are interested in, and I'm happy to share the slides. I've got a bunch of slides. I will. Maybe if there's a way before the end of the meeting, I'll make PDFs of all of my slide decks, and I'll.
I think I have your slides. You sent it to me before the event. Do you remember? I can send it to everybody. I will put it in a drive, and I will send the link to.
Oh, okay, great. And I'll send you another one that I just I made after I sent those. So.
Okay,
yeah.
perfect.
Great. That's perfect. Thank you. Okay, yeah. So I'm happy to do questions or whatever. Yep.
Yeah, so I'm looking at some of the questions here. One of the advantages of being the host is that I can prioritize my questions, even if it's not at the top of the list. So I'm scrolling way down because I posted a question, and actually, wow, folks, you have added so many good questions here. So
there are people saying
great.
in chat that they would prefer to go over the slides a little bit and after go to, what do you think? I don't know. I see people suggesting to go with the slides. Dan, what do you think?
Okay. I see slides popping up.
So, here's one that I thought was really useful. Is there any graphic or pic that describes the differentiation of each GCP service? So I've kind of wished for this, and I know Google offers so much stuff, right, that it's really hard to understand where's the top, when do you come down to the next level of stuff, what service is underneath what service. So I think people really want to learn how to answer questions, but maybe this high level, maybe you can answer this high level question about if I'm trying to learn this stuff, is there a graphic, is there a chart, EDR type thing that I can look at that really gives me a conceptual image of how all the Google services work together?
I will say I don't think there is a single one, but there's a bunch of them. And I think I've got an example here. Where is it? Of a flowchart. Here we go. There are flowcharts. If you go to Google and search for Google Cloud flowchart, you will see things like this. I'll see if I can.
Yeah, we already have them. The link.
Yeah, this is the best I have found in terms of anything like what you just described. And these are sort of like decision trees, like how do you choose which data store? Boy, that's a great question. Sounds like I should make one of those. Yeah.
Oh boy, good luck with that. I mean, that's actually one of the trickier things for me. For me, coming into the Google products, I came into Firebase, and that's a very user-friendly sort of scenario. and I had to go into the Google Cloud Platform Council, and that was the tab on the on the side. There are so many things that Google offers, and it was very hard to understand how these things relate, because they just have a lot of stuff. And I've also been in the Amazon Web Services space, and that's equally intimidating. So the first person to get a good picture wins, I think.
Well, and well, if I get around, if I can actually pull that off, I would love feedback. I'll share it with you all, and I'd love feedback on that, because it sounds like that would be really helpful. And I never thought of that. So thank you for all of you who asked that question. That's one of the great things. This kind of interaction is really helpful for me, because you bring up things that I do not think of, and I think that is a fantastic idea. So I will try and work on that.
Then I think the chat decision, everybody wants to go with your slides. I think everybody voted in there for the slides. So
okay. All right. So here's another one. You're creating a Kubernetes engine cluster to deploy multiple pods inside a cluster. All container logs must be stored in BigQuery for later analysis. You want to follow Google recommended practices. Okay, that's a phrase you watch out for, because there are specific things. So if there are two answers that are both like reasonably correct or technically true, one of them will be the preferred Google option. So you just need to be aware of that. Which two approaches can you take? Okay, a couple of things I want to point out here. Notice the sort of the area here, the checkbox is actually a square instead of a circle. So that's a visual cue that this is, you can make multiple choices. And if you're like me and you get like test anxiety and you let your test anxiety get the better of you, I have answered, checked off one answer that I know is right, and then I blow off and go to the next thing. And I easily get that one wrong if I don't like go back, check my answers, and see that I made a mistake. So from a test strategy suggestion, watch for visual cues. Oftentimes when you have multiple, you have to pick multiple options. There are 5 options, not just 4. And the boxes are like that. And they spell it out for you. They say, which 2 options can you take? So just, I have to tell myself to slow down when I see things like this. So, okay, so we've got to do a couple things. So we're working with Kubernetes engine. We want to take those logs and we want to put them into BigQuery. So that means we're working with Kubernetes engine, cloud logging, aka Stackdriver, and BigQuery. So let's see, we're going to turn on Stackdriver logging during the Kubernetes cluster creation. Okay, that sounds reasonable. I'll keep that one in mind. Turn on Stackdriver monitoring during Kubernetes engine cluster creation. Well, monitoring is useful if I want to know like CPU utilization, or set an alert if I'm going over like, if my memory utilization is greater than 90% or something like that. And I don't see any requirements for that in the question. So I'm going to kind of leave B to the side. I don't think that doesn't look like a likely candidate just yet. Develop a custom add-on that uses Cloud API and BigQuery API. Okay, I'm not even going to read the rest. Why would Google make us write a custom add-on to do something as basic as move logs around? So I'm almost convinced that's not the right answer. So I'm not going to come back to that unless I'm really desperate. Let's see, D. Use the Stackdriver logging export feature to create a sync to cloud storage. Create a cloud data flow job that imports the log from cloud storage to BigQuery. Wait a minute. Now, even if I'm not familiar all that much with how to get logs into BigQuery, why would I have to create my own cloud data flow job? I mean, maybe that's a possibility, but there's a lot of extra steps. Like I'm exporting to cloud storage, then I'm creating a cloud data flow job to get them into BigQuery. Maybe. But all right, I'll keep that one in mind. And option E is use the Stackdriver export feature. You're creating Kubernetes engine to deploy multiple pods. All container logs must be stored. Okay, all container logs. Okay, containers are tied to the engine. So yep, okay, that makes sense. So I think the reasonable answers are turn on logging. Okay, yeah, that makes sense. I got to be able to collect my logs. And I've got to be able to push them to BigQuery. And creating a sink, yep, I know logging. I'm familiar enough with logging to know it uses this concept of a sink for putting the logging data. So that's how I get to those two answers. Okay, let's see what we have here. This one is about, you have an application server running on Compute Engine. Okay, so I'm working with virtual machines, and it's in Europe West 1D zone. Okay, so I'm in a single zone. This is not at the regional level yet. You need to ensure high availability. Okay, yeah, so I've got to be in more than this zone. And replicate the server to the Europe West 2C zone. Okay, that makes sense. I'm going to get to another zone using the fewest steps possible. All right, what am I going to do? All right, I can create a snapshot from the disk. Okay, that's good because that gives me, everything. And I'll create a disk from that snapshot in the Europe West 2C zone, create a VM with that disk. Okay, yeah, that seems pretty reasonable. Create a snapshot from the disk, create a disk from the snapshot in the Europe West 1D zone, and then move that disk to Europe 2C and create a VM with that disk. That's extra, like, creating the snapshot and, creating a disk right in the zone where I want it to be makes more sense. Like, I avoid moving, so B doesn't sound right. Use gcloud to copy the disk to Europe West E2C zone and then create a VM with that disk. No, I'm not going to just copy the disk. I mean, I've got to make a snapshot. I've got to have a snapshot, like a consistent view of the disk. So I'm not just going to copy a disk. So C disk is another one. Even if I'm not quite sure, that one doesn't look right. Use the gcloud instance move with parameter destination zone. Well, I've never heard of that. So I'm instance move. I mean, that may be something. But going back up, it looks like, the least amount of work is just creating a snapshot and then creating a disk from the snapshot. So there, the correct answer is A. All right. Oh, square boxes, and there's 5. All right, this is probably a multiple choice, or I have to choose multiple things.
I have a question on the previous slide.
I'm sorry?
I have a question on the previous slide.
Oh, sure. I'm sorry. Yes.
There is a new feature called machine images, right?
Oh, I'm sorry. What is it called?
There is a new feature called machine images.
Oh, okay.
So is that the replacement of using this solution, or is a new update from that? Like, what is the difference between using snapshot and creating a machine image?
I am not sure. I would have to look into that. This may be an example of an older question, and it has been superseded by image. So I don't know off the top of my head, but if you want to connect with me on LinkedIn and ask me that question, I'll follow up with you on that one.
Sure. Thank you, sir.
Let's see. So, okay, I'm going to be picking 2 things, probably, maybe more. You need to select a transactional, okay? Transactional, the ones that a lot of the data services support transactional to some degree. There's different levels. Cloud SQL and Cloud Spanner are the richest transactions. Data Store has transactions. Cloud Bigtable has not really transactions, but they have consistency. They're guaranteed consistency at a row level. Maybe that's it. Relational data storage. Okay, well, the relational data storage systems, well, that immediately eliminates Cloud Data Store and Bigtable and BigQuery, because BigQuery uses SQL, but it's not relational, so I'll throw that out. Which 2 would you consider? Well, Cloud SQL is a relational data storage system, and Cloud Spanner is the horizontally scalable global relational managed service. So I would pick B and C in this case. Let's see. Oh, another Kubernetes question. Yeah, and you'll notice there are a number of questions on Kubernetes. Just because it is so important, I wanted to work with questions about Kubernetes. So you have a Kubernetes cluster with 1 node pool. Okay, and a node pool is sort of an abstraction within Kubernetes, and it's a set of nodes that are configured identically. And the cluster receives a lot of traffic and needs to grow. You need to add a node. What should you do? Excuse me. You could use gcloud container clusters resize. Okay, gcloud container, that's right. That's the command. Anything I do with Kubernetes engine is, and it's manipulating the Kubernetes engine itself with gcloud would have the container word in it. So that's right. With the desired number of loads. Okay, that makes sense. Use kube control container cluster resize. Oh wait, kube control is for manipulating things inside of Kubernetes, like node pools or pods, not the cluster itself. So I don't think B is right. Let's see, edit the managed instance group of the cluster. Oh wait, no. Google uses managed instance groups to implement Kubernetes clusters, and it manages them. So when you create a Kubernetes engine cluster, and say you have like 5 nodes, you can jump over into Compute Engine and take a look, and you're going to see 5 VMs spun up there, and they've got some naming convention based on what Google does. Now, I'm not going to go and edit those things to manipulate the cluster. So C does not make sense. And then D is edit the managed instance group. Oh, okay, again, editing the instance group. Okay, neither of those make any sense. So we have 2 options. So it comes down to, is it a gcloud command or a kube control command? So again, I'm going to think about this. It's working at the cluster level. So it's going to be the gcloud command. So that's how I kind of reasoned through that one. Let's see. You created an update for your application on App Engine. Okay, we're working with App Engine. You want to deploy the update without impacting users. What that means is I can't shut down my application and just let users hang out there. All right. You want to be able to roll back as quickly as possible if it fails. Okay. All right. So I want to kind of, I'm doing this tentatively. I want to do this as carefully as possible. So what should you do? Okay, delete the current version of the application. Okay, well, if I did that, my users would be disrupted, and I would have to reinstall it if something went wrong. So right away, A doesn't look right. And then deploy the deploy the update using the same version identifier as the deleted version. No, that doesn't make sense. That doesn't meet any of the requirements. So I'm pretty much going to throw A out. Notify your users of an upcoming maintenance window. Well, there again, I'm disrupting them, and I'm required to not impact the users, so B is immediately off the list. C, deploy the update as the same version that is currently running. Well, no, we don't want that. Deploy the update as a new version, migrate traffic from the current version to the newer version. Okay, so that looks more promising because that allows us to create a new version. So we still have our other one running. And with migrate traffic, we can slowly move over, say maybe 5%, 10%, 20%. And that way, if we run into problems, we can redirect traffic back pretty quickly. So we don't have to reinstall the app. So D is the correct answer there.
Sorry to interrupt. I have one question on the canary deployments and blue-green deployments. So
okay.
Will we have questions in the exam for them? Blue-green deployments and canary deployments, and also A and B testing. Will exam cover this type of questions as well?
That's the kind of question you'll get on the architect exam. A/B testing, possibly, but it would probably be almost like that's part of the scenario. Oh, you're doing an A/B test and you've deployed, 2 versions of the applications, and somehow the answer is, how do you route traffic? Or, what would be a command or something like that to do it? So you might get that at like a more detailed level where you have to think about conceptually, why would you use A/B testing at the architect exam? And in the cloud engineer exam, it would be somebody's already decided you're using A/B testing, and how do you, and then specifically it'll ask you, how do you do this specific task? Yeah. That's a good question. Yeah.
All right. Oh, go ahead, Dan.
Oh, no, I was going to say, so that's it for sort of the kind of cloud, the test strategy and things like that. And now I've got a bunch of slides where I talk about like compute engine, Kubernetes engine, app engine, all that stuff. I'm happy to dig into that, or we can do more questions.
Then one more question regarding Cloud Armor.
Well, hey, if we could, let's go ahead and put questions in the chat or in the side-low. But go ahead with your and speak your question, Nako. Yeah, go ahead. I'm listening. We're all listening, Nicole. Did I understand you right?
Go ahead,
Yeah.
Chad.
Yeah. So this is regarding Cloud Armor. On the can you please explain a little bit on the Cloud Armor, because on the theory it's very bit difficult to understand. Maybe you can help with basic understanding.
I'm sorry, my connection went bad. I wasn't. What is the topic? I explain which.
Hello. So I was asking.
Can you type? It's kind of difficult to understand.
Yeah,
Nicole, can you go ahead and type your question in? Let's go.
Yeah,
let's go ahead and continue to use the chat, and even better, use the side-low to present your questions. And then, because sometimes it can be difficult. I was trying to pick that out. I know that he's asking some of the differences.
Right.
There you go. There you go.
Yeah. Let me just take a quick look. Yeah, that is a new service.
Something about Cloud Armor or something.
Yeah, I'm just
difficult to understand.
Yep, and I don't remember exactly. I'm actually going to Google it right now because I'm not exactly sure how much is included with Cloud Armor. And if this is like the beyond security, yeah, this is a great question. Okay, I'm just reading this. Denial of service attack. Web.
What happened?
Uh-oh.
Then you are muted. Then you are muted. Can you unmute yourself?
He's
I posted in the chat the link for the questions, so you can post your questions. I think Dan is muted.
Hey, I'm sorry about that.
No worries.
I apologize. Okay, Cloud Armor, yeah, it's a new service, and it's called a web application firewall. And if you're familiar with networking and the 7-layer model, like the OSI model of networking, there's like at the very low level, you have like the hardware, and then like at level 3, you have like TCP, IP, and when you configure a network firewall and you block certain ports or certain protocols like ICMP, you want to block that. That's a network level firewall, and the logic, your rules are basically at the level of like ports and protocols. With a web application firewall, you're at what's known as layer 7, so the top of the sort of application stack, and your rules are associated at like application logic level. And so you can create rules like only let HTTP traffic that has a certain payload structure through. Web Armor is a web application firewall. So it allows you to create rules like that to protect your application. So in addition to setting up firewalls that like block traffic, this allows you to analyze the traffic that does get through the network firewall and apply more logic to it so that you can filter out things. And it also gives you access to like Google's technology for like denial of service attacks. So, if somebody wanted to hit your VMs with a DDoS, this would basically protect you from that. And which is great because, I'm not a networking expert. I don't want to worry about DDoS. So that's where Cloud Armor comes in. Great.
That's great. Yep.
I'm so glad. Great question. Yeah.
Questions from the Slido, please.
Yeah, here's another one, which I thought was interesting is what's the difference between Google Run versus Google App Engine versus Cloud Functions, right? I think all of those are compute instances. Is that the right way of saying it? but some of them are more on demand. Like what would, if we're being asked about the difference between those, or if we should be using one or the other, what's the secret there?
Okay. Cloud Functions is event driven. So a Cloud Function only executes in response to something happening, like a file being uploaded to cloud storage or a message being written to a Cloud Pub subtopic. So the distinction there, and somebody put it in the chat, and thank you, all three services are serverless. So that's their common thing. But they are different in that Cloud Function is event-driven, and you can only write code or write a function in a certain set of languages. And that function could only run for some period of time. I don't remember what the longest period is, maybe 10 minutes, or it might be like a minute by default, but you can extend it up to 10. So Cloud Function is very short running, and it's a way of responding to an event. Cloud Run and App Engine Flexible both run containers, Docker containers. Cloud Function does not run containers. It runs just a single piece of code, and well, in the background, your code is running in a container somewhere, but you don't have access to that. In Cloud Run, you get to configure, and App Engine, you get to configure whatever you want in your Docker engine, and you can run those. Cloud Run is a managed service for stateless containers. So you can use Cloud Run. Cloud Run is probably going to be where you would want to run your containers if you want to have minimal management. App Engine Flexible may give you more features with regards to things like A/B testing and routing and things like that. So you might want to continue to use App Engine there. I don't know if Cloud Run supports that yet. Otherwise, you could choose either. But
that's great. That's really good. Yep. So here's a question more about the exam itself. Okay. And this says, for the online proctored exam, would you need to remove or cover up books on the shelf, such as those behind Dan?
You know, I don't know. I think as long as you don't have them open and reading from them, I think that's the critical thing.
So give us a little, I think I know, but give us a little context by why they're asking that question. I'll jump in. It's fun. When you're taking the test, it's fun because basically you have to stay in front of the camera, no potty breaks. The screen is, looking for you to stay put, and maybe, I wish I knew what it was doing to figure out whether you're cheating or not, right?
Yeah.
But I think that's a fun question. Yes, if you've taken these tests, you know that there are restrictions, and I don't quite understand them. So I thought that was fun.
Yeah.
Another question, Dan, for you. What kind of roles can we apply for after we get certified as associate cloud engineers? I think this is an important question.
Yeah, it really is. And it would basically be any kind of, anything, of course, with the name cloud engineer in it, or from a DevOps perspective. Like an SRE, a site reliability engineer. Basically, it used to be years ago, people would have the label like system administrator. Back when we ended up managing 1 or 2 machines. But yeah, so I would go with anything that has like a system administration title, cloud engineer, DevOps engineer. Although with DevOps engineers, sometimes it's more like application development. Site reliability engineer is a good one. Yeah, I would say those are probably the main ones.
Here's a good question. Okay, this is something that I've struggled with is, hey, Dan, what would be your biggest tip to improve the IAM part of the exam? So, right, identity is a big part of this. Mm-hmm. What do you have to say about that? To improve the quality of the exam, or improve your chances of getting the IAM questions right? Let's go with how to do a better, how to take the test better. Let's not try to improve their exam. Okay,
I would say Oh, I would say look at permissions, like how permissions are named, and look at how roles are named. There is a structure to them. And I would say, read enough of them so you can kind of recognize a role or permission name that you may have never seen before, but you can pick it apart. Oh, this is about BigQuery, and it's an admin thing, and it's something about a read, and it's like, because there is a structure to those. So I would say get familiar with both specific roles, like the names of those roles and the names of the permissions. I would say that's one thing. I would say just hands down, no question, the difference between predefined roles, custom roles, and primitive roles, and when to use each.
Yes. Yeah.
This
has changed a little bit recently, hasn't it? There's been a little bit newer update to how the IAM roles are managed and distributed. I just ran into this recently, and so I thought that was a great question because, like you said, there were predefined roles, but the ability to create custom roles is pretty advanced in the last year. And also, some things that I used to have access to, they've really buttoned that down, and there's a lot more roles but maybe you can talk about that.
There is one more question, more personal for you, Dan. Are you planning to write a study guide for the rest GCP exams like Cloud Engineer, DevOps, Security, etc., and Cloud Fellow as well? Thanks.
No, I'm afraid I've blown my wad. I wrote 3 books in 2 years. I'm taking a rest. That's a little too much. I don't know if others are in the works, but yeah, I don't, at least not right now. I don't foresee it in the next year or so.
Someone asks, is your course enough to complete? So if we take your course, is that enough to complete an exam? Right, anonymous asks.
Yeah.
I'll read it. So yeah, the specific question is your course enough to pass GCP Associates, or do we need to supplement with other courses?
I would say you need to supplement with hands-on work. Like if you read the book or took Coursera, did any one of those, and then did sufficient work hands-on, then you can pass. The critical thing I would say is, these other resources like Coursera or the book, they give you a sense of the breadth of what's covered on the exam, and that's really important. And also some of the details that you need to know, like, nearline storage, you're going to access that less than once every 30 days. That's the kind of stuff you can pick up from the book and the course. And that's, one of those or 2 of those is probably enough for that. But I'd say the critical thing is work with GCP in the console and the command line. Yeah. So the answer is no course, no book. Like I would never recommend like reading a book or reading all the books out there, taking all the Udemy exam courses and doing all the quick labs and then walk into the exam. I can't imagine how anybody would pass. You really have to, just sit at the console.
Use quick labs for practicing, right? Lots of quick labs.
Yep, lots of quick labs. And quick labs are great. I'm a huge fan of those and I recommend doing them, but that's not enough.
Yeah, exactly.
Linda, do you have another question?
No, I was reading from, but you can go.
Yeah, so there's another question here. Let's see. It's fun to watch these because as people vote, they shuffle in order. Oh gosh, I just had a good one and I lost it.
Okay,
Let's
I have
see.
one. How
which
experience of
GCP association?
Oh, I'm sorry. Can we repeat that?
No.
Sure. Which quick labs is a must for GCP association prep? We were just talking about quick labs. Which one would you recommend?
Gosh, I don't know. I haven't looked at quick labs in a while. I don't know what's out there. Let me just see if I can do a quick look and just see what's available right now.
And I'll say this out loud. I've only experienced quick labs through Coursera. Maybe there's another path. Is there a list where you can just go through them independently of Coursera?
Yeah.
Yeah, there's quick labs.
There is.
QWIKlabs.com. And I'm just looking through here. Tour quick labs, creating a virtual machine. You want to do creating a virtual machine. Compute Engine, Quick Start Windows. Getting started with Cloud Shell and gcloud, I'd recommend. Kubernetes Engine, Quick Start, yep. Set up network and load balancer, yep, I would recommend that one. Yeah, I don't see others listed. That's Google Cloud Essentials. I'll see what else is around.
Here's a question I really like. It has to do with whether to learn the shell or, hold on, let me find this again here. Or the GCP console. That's a kind of a high, that's a deep question, right? Should we prioritize Cloud Shell or GCP console?
Actually, they're different things. Cloud Shell is basically it gives you like a bash shell. It's like a command line, a bash command line that runs in a small container on the cloud, and it gives you access. And once you start up Cloud Shell comes with gcloud already installed. So it's really all you're doing is when you're in Cloud Shell, you are using gcloud. So if you learn gcloud, you can run those commands from your local machine, or you can run them from within Cloud Shell.
It's really just whether you're running it locally or whether you're running it in the cloud with their instance.
Exactly, right. So I use Cloud Shell all the time because it's, I don't have to like jump back to my machine. I can do it in the browser. It's really great. And basically and also your Cloud Shell, like your history and stuff will persist. So if you shut it down and start it up again, you can go back and use your history.
Oh, I didn't know that. That's pretty neat. We're getting some love in the chat for Cloud Shell, so that's great.
Yeah, I love Cloud Shell. Yeah, definitely. It's a well-earned love.
All right, I'm just scanning some of the other questions here. Linda, let me know if you have one that you see that's pretty good here.
Then how transferable are experience of getting certification from other cloud providers such as Azure and AWS?
And so the question is, does it help to have?
Yeah. How can you transfer your experience that you already have as AWS or Azure to Google, to GCP?
Sure. Well, from an architecture perspective, it's pretty straightforward because it's very similar. I mean, we work with the same concepts. I mean, designing scalable, reliable, distributed systems, it's pretty much the same. So things like understanding how to use load balancing, messaging, different like cloud native design patterns. So at an architecture level, it transfers over pretty easily. Conceptually, like the concepts map over. Things like the gcloud or the AWS command line, they're really different. So you've got to learn the specifics of different things. Also, like running Kubernetes, if you spin up a Kubernetes cluster in AWS and use kube control, that's the same as using kube control in a cluster that you spin up in GKE. So I would say if you're an architect, the stuff will transfer fairly easy. At a cloud engineer level, there's probably less that transfers, although you probably get a little practice, like the tests are similar. So, test taking strategies are probably carry over as well.
Yeah, there was a similar question. If somebody has already AWS Solution Architect certification, which GCP certification and material would you recommend it? I know that there is a course that is special for these people in Coursera, but if you can say more about it.
Yeah, in that case, if you've already done the architect on AWS, you might want to go straight for the professional cloud architect. But again, get some hands-on work. And the architect exam uses 3 case studies. So when you go look at the exam guide for the architect, also look at the case studies. There are 3 case studies, and you want to know those inside and out before you go into the exam.
That's great. So I have the second question I'll ask has to do with the order of should I do this and then that and then this. But before I ask that question, let me come back to someone wanting to know what you're going to do next. So are you planning to write a study guide for the rest of GCP exams? Example, cloud engineer, DevOps, security.
It was already asked.
Right?
Yeah.
Oh, that's right. That's right. You said you've written 3 already this year. Okay. I guess I'm anxious for your next one. So maybe I'm just re-asking the question. And so anyway, that next question then is a JavaScript developer here. If you're transitioning from JavaScript, just, you know, I'm maybe a full stack, how would you transition into cloud, DevOps, site reliability engineer, besides getting the certs?
Oh, that's a really good question. So basically, so someone who's, you know, a developer and is focused primarily on development and now wants to move into more of the like cloud engineering architecture kind of thing. I would say, so there's sort of two forks. There's what can you do on your own and what can you do in your job? Like if you're in a position where you're maybe a developer, I would say, you know, as much as possible, try and do as much operational work as possible. So there are things you might be able to do as a developer, like if you can set up a continuous integration, continuous deployment, CI/CD environment, you can do that in Google Cloud. Or if you're not using, maybe you're using GitHub, but maybe you know, if you can transition and use Cloud Repository, I would say start using the Google tools like Cloud Repository, Cloud Builder. Start using those as much as possible in your work, you know, whenever you can do that. And then also sort of on your own, pick a project. Like imagine like build an application all the way through, especially if you have backend experience as well. You know, set it up in a VM and use cloud data store as the backend, and you know, just get a toy database running, something like that, and then move that over to a container and run that in Kubernetes engine, then run it in Cloud Run. Like that's, if you can do that kind of thing, then you're really well on your way to being an engineer.
There is another question for you, Dan. What are the advantages of GCP over other providers, and why is growing so fast?
Yeah, I get that question a lot because I actually started in AWS. I also have AWS certifications. I like AWS. I'm actually spending most of my work time these days in AWS. So I'm not critical of AWS or Azure or any of the others. I use GCP and like it better because there are lower barriers to entry to get things done. If you go into AWS, there are a lot of services, there are a lot of pieces. If you think of this as a puzzle, when you're putting something together in the cloud, when you go into AWS, it's like a 1,000-piece puzzle, and you've got to put all these pieces together, especially like at the low level, networking level, security groups, you have to configure NACLs, network access control list, and there's a lot of moving parts that you need to configure. You don't have to do that in Google. In Google, you go in, you create your VM, you know, by default, things are set up. So for example, your VPC is global. You don't need to worry about having to set up routes between different regions like you do in AWS. And so with Google, part of it is it's much easier to get up and running, get your infrastructure up and running. The other thing is that they have services, core services, which are really valuable for building like cloud native applications, like Cloud PubSub's there, BigQuery is there, Bigtable is there, Dataflow is there. And there's a lot of support for containers. Years ago, like, I don't know, maybe like 5 years ago, people would complain about Google Cloud and say, you know, oh, Google Cloud's only a good option if you want to run your applications the way Google does. And that's true. That was definitely true 5 years ago, and it's still true to a large degree now. But the thing is, more and more of us are running our systems the way Google does. You know, we're using containers, we're doing continuous deployments. So in Google Cloud, it's much easier to get up and running and going, and it's much fewer headaches, I have found. So now there are disadvantages. You know, I think there are more tools, more services. So if you have like some esoteric specific need, there's probably a service for it in AWS, and there might not be one in Google Cloud.
He's asking for the slides. As we said, they will be sent after the meetup. All the GDG leads will send to their attendees, so do not worry for that. You'll receive the link for the slides. If you have other questions about the meetup group for preparing for the exam, you can join us. All of our GDGs, we will meet this weekend again. I think it's tomorrow, and you can have all that questions answered there. So all the questions that are not related to Dan, let's skip them, please.
All right. So what is what is left for our event today? Right. How are you feeling, Dan? Are we in a good spot?
Good. Yeah, I'm happy to do whatever. I think we've covered a lot of questions. If people have other questions, I'm happy to answer them, or asynchronously, if you want to send them to me on LinkedIn, I'd be happy to answer. I don't want. Yeah, I don't want to answer.
I think
you don't want to kind of raffle time, right?
Yeah,
raffle time is what people are asking about now. Yeah. We've rolled the credit for about as long as we can, and now we need the spoiler.
1 second, I will share my screen. And before we go to, are you okay with that, Dan, or do you want to add anything else before we go any further?
No, I'm all set. I'm just going to jump over and I'll send you the newest version of my other slide deck and get that to you right now. So, I think I'm good. Thank you.
Thank you.
Yeah, very good.